Starting our discussion on Markov processes, in part 1, we took a look at this problem right here and we summarized it with this transition matrix. So we had two states, working, not working, working, not working. And these numbers were 0.80, 0.20, 0.30, and 0.70. And then we had this initial state matrix, working, not working. So back in the 60s, we knew that by the census, 40% of women were working, 60% of women were not working. And we're using that sub-0 here, or sub-O, for the original state. So these would be the percentages of mothers working and non-working. And then what we want to know is, what is the probability that the next generation, what are these probabilities, working, not working? So this is the mothers back over here in the 60s. This is their daughters, right, the first generation after that. This is the initial generation, then the next generation, the daughters, and then what numbers go in here? Then the granddaughters, what numbers will be put in here? What percentage of granddaughters would be working and not working? And then great-granddaughters, what numbers go in here? And then dot, 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 some nth generation down the line. What probabilities would we put in here? That's where we're headed. So we can get an idea of how to do this. I'm going to draw a tree diagram, and I'm going to label things like this. This is generation 0, right? So that's going to be initial generation. And then here's generation 1. This would be the next generation. So this would be the mothers and the daughters. Let's draw a tree for this. So we're going to start here. Now, here's what we do know. That working, not working, and in the 60s for the mothers, this was 40% of women were working, 60% of women were not. Now, we're going to use the transition matrix, I put it in over here, to get the next branches. So if the mother's working, how do we get to these numbers here where the daughter is either working or not working? We'll use our transition matrix, right? So in one generation, if one generation is working, there's an 80% chance the next generation will work, right? We're going column to row. So if we're working, that's where we are over here. If we're working, there's an 80% chance that the next generation will be working, and a 20% chance, right, over here to here, 20% chance of not working. And then what about down here, this branch here? If the mother is not working, what about the daughter working, not working? So again, using our transition matrix, if we're in the non-working column, there's a 30% chance of going to working. So if we're down here now, not working, there's a 30% chance of taking that branch and a 70% chance of taking that branch. So here we are at generation 0 right here. To get generation 1, the daughters, right, generation 0, the initial generation is the mothers. Generation 1, first generation after that, is the daughters. So that's what we want. We want to get P1. So to get P1, we need working and not working. So here's working. We can get working here or here, not working here or here. Let's get all these numbers. So right up here, working and working. That's going to take us to what? 0.40 times 0.80. Down this branch then, 0.40, 0.20. This will be a 0.40, 0.20. And this branch, oh, what a mess. This branch here, not working to working, all right, that's going to give us a 0.60 and a 0.30. And then finally that last branch, not working to not working, is going to give us 0.60 times 0.70. So here's P1. This will be the next generation, the daughters, working, not working. So how are we going to get working here? So where do we get working? Working comes from this branch here, or plus this branch here, right? We can get it here, or plus here. Let's write that. So we're going to get this number here by taking this multiplication and sum, 0.40, 0.80, plus 0.60 times 0.30, right? Let me be sure I have that. What have I got here? 40 and 80, that's coming from here, or plus this one, 60, 30. I've got it. Let's get this number down here. Now this is not working. We can get not working from this branch or this branch, and the or is a plus. Let's write those numbers in. So that could come from 0.40, 0.20, plus 0.60, 0.70. We can compute these, so we'll get P1, the daughters. This will be working, not working. What do we get here? We get 0.32 plus 0.18, and then 0.08 plus 0.42. We can add those, so we'll get P1 working, not working. Oh, look at this, 0.50 and 0.50. So here's where we are right now. We've got P sub O, P naught we call it, working, not working. This is the percentages for the mothers. Started off 40% working, 60% not working. Then we go to their daughters. And now what we found was working, not working. And this is going to be 50%, 50%. Now, what we would like to do is get P3. What about the granddaughters? So we could do this by going through the same reasoning. To get P3, we could get this by going through the same reasoning that we got these numbers right here, right? We could draw a tree and make all these computations. But there's a more efficient way to do that. Let's see it. Let's look at this multiplication here. This is the transition matrix and then times the state matrix. So this becomes, all right, here's our transition matrix, right? We were at working, not working, working, not working. We were at 0.80, 0.20, 0.30, 0.70, and then here's our P naught. This was, what do we have, 0.40, 0.60, right? That's the mothers, working, not working. Now let's take this product. So what we're going to get is this. Remember how to multiply matrices? Over and down, right? First and first, down, second and second. So this becomes 0.80 times 0.40 plus 0.30 times 0.60, and then second row, first column, over and down, first and first, 0.20 times 0.40 plus 0.70, 0.60. But now, do you recognize this? You recognize this one right in here? Here's what I'm going to do. I'm going to put from our last computation, this is exactly P1. Do you remember? If you go back to our last page, P1 was this one right here. It's just written slightly different. Instead of 40-80, it's written 80-40. But it's the same thing. And if you compute this one, what we get here then is that P1, working, not working, is the 50-50. Right, so what that means is that we don't have to go through that tree diagram every time. We can get from one generation to the next by multiplying the current generation by t. I'll summarize it. Here's where we start. I get P1 by multiplying transition matrix by my original state. That's where we got P1, right? Now, P2, I claim I can do this. If I multiply the transition matrix and P1, I should get to P2. This is the granddaughters, right? So P naught is the mothers, multiplied by transition matrix gets us to the daughters state. Then take the daughter state, transition, that gets us to the granddaughter state. Then great-granddaughters would be T times P2, ... Any generation is T times the one that came before it. All right, let's just try this. Let's get P2. So P2 is going to be T times P1. So this is point, let me see if I can write that, 0.80, 0.20, 0.30, 0.70 times P1, which is that 50, 50. And this is going to give us 0.80 times 0.50 plus 0.30 times 0.50. And down here we'll get 0.20 times 0.50 plus 0.70 times 0.50. All right, and then when I computed those out, here's what I got. I got P2 to be working and not working, and for these numbers I got 55% and 45%. So here's where we are so far. P naught, I'll just summarize it. Working, not working. These are the mothers back in the 60s. So it went 40% working, 60% not working. Then we came to P1. And P1 we could get by doing this. Take the transition matrix, multiply the matrix, the original matrix state right here. So P1 is going to be T times P naught, and what we got for that one was 50, 50. And then transition matrix times P1 gave us P2 for the granddaughters, and that gave us 55% and 45%. And then we could go on, right? We could get P3, the great-granddaughters. But look at this trend. See what's happening here? We started at what? Mothers were 40% working, 60% not working. And then one went up, one went down. It went to 50-50, working, non-working. Then for, this is mothers, daughters, granddaughters, went up to 55% working, 45% not working. So what do we expect to have open here? And dot, dot, dot. What do we expect to happen down the line? Well, to go farther down the line, you know, like if I wanted, what if we wanted this? What if we wanted P8? Well, P8 would be T times P7. But then I need P7. So that means what I would have to do is get P6. Right? So to get P7, what do I need to know? I need to know P6. And to get P6, I need to know P5, and so on. Well, this is cumbersome, and there's a way out of this. Notice what we could write here. I'm just going to do this for maybe P4. Say for P4, I could get that by doing this one here. But notice, what is P3? All right, P3 is what? T times P2. Then I get T times T, so I get T squared times P2. But now I need P2. So this is T squared. How do you get P2? Well, that's T times P1. And then T squared times T, that's equal to T cubed P1. But what's P1? So this is T cubed times, now P1 is T times P naught. And T cubed times P, that's T to the fourth P naught. So that's P to the 4. So can you see this pattern here? If I want the fourth generation, I want the fourth generation. So what can I do? I can just raise the transition matrix to the fourth power and multiply it by the original state. So I'm going to make a general statement here, and that statement is this. If I want any particular state, say the nth state, I'm going to raise the transition matrix to the nth power and multiply that by the original state. Let's give this a try. I'll write our general formula here. The nth state is the transition matrix raised to the nth power times the original state. And as an example, let's get P2, because we know what that is, right? That was 55, 45. So we're going to take T squared, right? These match. The nth state matches the power. So let's see. I want 2 and 2, and then P naught. So this is going to be, here's our transition matrix, 80, 20, 30, 70. I'm going to square that, and then I'm going to multiply it by P naught, which is the original. This is the mother's, 40, and 60. Now, I did this on my calculator, so I put in, here's what I put in. For my calculator, I put A being this matrix here, and then squared it, and then multiplied it by B, which is this matrix here. So really, on my calculator, that TI-84, I'm doing this. I'm getting A squared times B. And sure enough, when you do that, you end up with this, 55, 45.